This is me. I am very fortunate enough through all the work and community efforts that I've done to be a Microsoft MVP, which gives me access to the Microsoft Teams and a lot more information that I can get prepared ahead of time to basically share it with you guys. I'm also one of the co-owners of a company called Holosoft. Holosoft, with my partner back there, Travis, is basically a company that we formed to focus on augmented reality, virtual reality, and mixed reality, which is what Microsoft calls this. It is a billion-dollar emerging market, and really where I think by being here, you've served yourself in a good way, because at all companies in the next 5 to 10 years, they're going to have some sort of augmented or virtual reality application. They're going to have training on those devices. They're going to have, if you have IoT devices in your place, IoT devices that don't have a display on it, you're going to basically be able to use mixed reality, augmented reality to basically add a display on top of that. And we'll kind of go over that stuff. But by being here, you're positioning yourself to really be the guy or gal in the company that the company goes, anybody know about any of this mixed reality, augmented reality stuff? And you go, yeah, I know, totally. We got it nailed. So I also run mad.net, which is the Madison.net user group. Please feel free to join us. Hop on our website. We have great hosts. What? We do. It's about Signal R. It's almost like you saw it in the first session. All right, so what we're going to go over today, and there's a lot of content to basically put in there because this talk is one I usually give for longer, but I want to make sure that I don't skip out on anything for you guys. So we're going to walk you through from very beginning to end. We're going to walk over what is mixed reality. We're going to walk through what are spatial anchors, setting up your Azure Spatial Anchor service, building a Hololens app, building an Android app, and you're going to find out there's not a lot of difference, which is great. Mixed reality resources for you, so you can basically take those and move on, and then we'll have time for questions. All right, so what is mixed reality?
Microsoft HoloLens brings holograms into your real world. Using transparent lenses, spatial sound, and an understanding of your environment, holograms look and sound like they're actually part of the world around you. That is mixed reality. With Microsoft HoloLens, holograms are viewed through the holographic frame centered in the middle of your view. This preserves your peripheral vision, so you can move freely and connect and collaborate with people around you. Holograms in mixed reality don't block out what you can see and hear. This enables you to engage with digital content and tools alongside the objects in your real world. Holograms can be world-locked in a physical location, so you can walk around them, or they can travel with you. You can even hear them in 3D with spatial sound. Microsoft HoloLens is the world's first fully untethered, self-contained holographic computer. With the mixed reality experience of HoloLens, you can stay in the real world and interact with real people as you simultaneously explore 3D in 3D.
So now let's go to what are spatial anchors.
Anchors would start by noting prominent physical or geological features and then fill in details by placing items relative to these markers. As the cartographer explored more and more of an area, the accuracy of the map would improve. HoloLens maps a room in a similar way. Tracking works to recognize surfaces and features of a room. When holograms are world-locked, that is, placed relative to real objects, then the holograms are anchored relative to these surfaces. As the user moves around a room, the details of a room continue to be mapped so that the placement of holograms relative to these surfaces becomes more accurate and solid. Since tracking is more accurate at closer distances, the image the HoloLens has of a room continues to increase in accuracy over time as the user moves and views room objects from various angles. You can even have multiple anchors in a world-locked scenario, with each anchor having its own coordinate system. The holographic APIs help you translate coordinates between the different coordinate systems. As the HoloLens continues to track and get better information about its environment, the translation between these coordinate systems will get more precise. Best of all, this information can be persisted so that the HoloLens knowledge of a room can be retained for the next session or shared with another device. This opens up many possibilities to create imaginary shared worlds.
So spatial anchors in and of themselves is not a new concept for HoloLens. But being able to basically have a service that is able to share those spatial anchors between different devices, including more than just the HoloLens, is a brand new thing that was just released at GDC about a month ago. So this is all brand new cutting edge things, cutting edge services, and we'll get into that as well. So what's our objectives here? If you look at this, this is how we're going to basically view things next 5, 10 years, maybe even sooner. You're going to basically have a group of individuals, and they're not going to have a model. Think of all your architects. They're going to have a model that's going to be holographic. They're going to be able to walk around it. They're going to be able to coordinate together around that particular model. Also, think about your factories, and this is where I was talking about IoT devices. You're going to be able to basically walk around your factory, your warehouse, all these different scenarios, and look at all the metadata about all these objects. Think about being in a museum. You'll be able to walk through a museum, look at a piece of art, and say, oh, that's I like that picture from that painter. I want to see more. And then a curator, a virtual curator, will pop up next to that piece of art, give you more information. You'll be able to swipe through and look at the other paintings. So really the next generation of computing, and Microsoft is betting on this, and so am I, is this is going to be your next evolution of computing, where you're basically bringing all this metadata in the world to something that's going to be wearable that somebody's looking at. So here's our objective with Azure Spatial Anchors. Take a phone, an iOS, and then basically take that phone, and then I've mapped a point as an Azure Spatial Anchor, and now I put on the HoloLens, and it's found that same one. Using those sensors from both of those devices, it was able to identify a location, and now I'm able to share that location between the devices and then render, for example, in this case, a signpost. And this same thing if you're walking through that factory. I'd be able to tag all of those devices, all of the machinery, all of those things that were basically physical objects in your environment, and say, this is where I want to basically have this IoT heads-up display. Here's where I want to have a warning sign. So there's lots and lots of huge potential for this stuff. So let's go through some FAQ. These are all the ones as I've been talking with people. I want to make sure that everyone kind of understands where we are. But if you have more questions as we go, please ask. I'll go over any questions you want. But what devices support Azure Spatial Anchors? Supported devices require the ability to scan their surroundings. So they have to have cameras, depth sensors, and the processing power to show 3D holograms. What that is, HoloLens covers that. iOS devices that support ARKit. Android devices with AR Core support. Sadly, no Microsoft Surface support. They're my favorite tablet, but there isn't a support because they haven't exposed the SDK for that at this point in time. Fire. Yep, great question. So the question is for the remote viewers is, can you have language-specific instances of those objects based on the person basically viewing them? Absolutely, 100%. What you're storing, and we'll go over, is you're actually storing a location. Then what you do with that location, what hologram or what language you basically come up with based on that is part of your application, and you can localize that. Great question. Love it. So are the holograms being saved as in the Azure Spatial Anchor service? Nope. The holograms are part of your application. This was, again, a big misconception when I gave this talk before, and I want to make sure that I'm covering it. What is being stored is the anchor location within the environment. You then load your holograms once that location is found by the device. So you're completely in charge of what it is. You're literally storing a 3D space. What information about the environment is transmitted and stored in Azure? Are pictures of the environment transmitted and stored? So again, if we have locations, sensitive locations, government locations, does anyone remember Pokemon Go? I'm level 35 still, but we're good. It only gets up to 40. It was great for us as developers because it got the term augmented reality in everyone's vernacular for a little while. And they're coming out with a new Harry Potter one, which will be really cool too. So it'll be back. But in particular businesses, they banned Pokemon Go because they thought they were basically sending videos up to their service. So that's a big concern. Will we have that same problem here? And the answer is no, luckily. Pictures are not stored or sent to the device. Instead, when creating or locating anchors, what the camera/sensor sees are converted on the device to what's called a sparse point cloud with a hash, further identifying the visual characteristics of each point. What does that mean? So if we look at this picture, I'm going to use my fancy-dancy spotlight. Ooh. So if you look at this guy right there and kind of the scene, what it does is actually converts it to this three-dimensional sparse point cloud. And you'll actually kind of see some of these points. There are different, potentially different hash algorithms saying maybe this point right here has got brown, maybe it's a rough surface, maybe it's whatever. So the more information that we can basically pack into this sparse point cloud and those hash algorithms gives you a better way to identify what that object is. How does this basically work further on? Does it require internet connection? Yep. Now, this is all basically all connects up to Azure. It allows us to continually utilize that service. In the future, however, I expect to be able to cache these things for a location. I expect more edge computing devices. How accurate are the positioning of the anchors? So many factors affect the accuracy of the stored anchors. Lighting conditions, you'll note that. So if you record an anchor in a completely different lighted scenario, it may not recognize it because those hash of those individual points may be reading a different reflectivity, so on and so forth. I've had pretty good luck in most lighting getting the same spatial anchors, but if you're really dark, it's going to be really hard for it to define. Objects in the environment, you want to basically have, and we'll go over this a little bit more, objects in the environment, you want to work on static objects. I don't want to position my anchor on Cameron because I know he's not going to sit there forever. He's going to move. But the chairs in this here, the tables in here, I can basically utilize those static objects in the room to position my anchors because it's going to do like what we saw in that sparse point cloud. It's going to look at what that object is. Even the surfaces which the anchor is placed, like I said, because it's basing that hash algorithm based on that. And this is one that we're still playing with, differences between devices sensors. So we can do it on the HoloLens, we can do it on Android tablets, and I get great, if I go from one HoloLens to another HoloLens, I'm having great placement, great retention of where those anchors are. We have a little bit more problem when we go from one device to another device, and my speculation at this point in time, I'm going to talk with the team more on it, is that I think the cameras are picking up, this has depth sensors, the Android devices have obviously just the cameras, in this particular case for that one. I think you're getting differentials in your sparse point clouds based on that. Questions, comments? No. If you encounter an environment where accuracy isn't meeting your needs, enable logging and diagnostics. So they built in a really nice logging and diagnostic system to this so that we as developers can go over and say, what we're not getting really good accuracy, let's figure out why. Can you programmatically place an anchor? For example, set one based on GPS. Nope. Anchors are set via the device. In the future, I hope so. I hope we're able to do more along that line because they make a Pokemon Go-esque game utilizing the service. I don't want to have to walk everywhere and figure out where all those points where they're going to generate are. So it may not be the story for this particular service to make that Pokemon Go game, but I think we're going to eventually get there. I think we'll probably be able to do some sort of hybrid where it appears on a GPS base or whatnot. But again, the HoloLens 1 and the new HoloLens 2 don't have a built-in GPS. But our Android phones do, some of the tablets do. How long does it take to create an anchor? Generally, I'm going to summarize this. It takes a couple seconds to do so. But the most important thing you need to think about here is programmatically, when creating anchors, you want to place a local anchor in your application and then sync behind the scenes. So I want to basically walk around, and we'll show this in the code, where I place an anchor. It sits there. I can see it on the device. And then behind the scenes, I basically do that synchronization to the cloud. So to me as a user, it looks totally solid. It didn't take any time at all. Who has access to the anchors that I place? Anchors are isolated by the Azure account. Only apps to which you grant access to your account will be able to access anchors. So this isn't a global service. You create an Azure account for your Azure Spatial Anchors, and then you utilize those keys to differentiate your service versus somebody else's service. So your anchors sit in yours and somebody else's anchors sit in their service. And we'll walk through setting up that Azure account as well. Best practices for placing anchors. And this is what I was talking about. This room, great. This room, more difficult. Should I publish my app using Azure Spatial Anchors now? Not yet. It may change. It's currently in preview, and developers are encouraged to start building their applications and provide feedback about the product. And I'll actually tell you where you can provide feedback. And then I think this is one of the last ones. Pricing, free for now. We'll see how it works out in the future. I think it's going to be somewhat akin to the way they do cognitive services, which is you get 10,000 or so free things a month, and then everything over that, so you have a fraction of a penny to basically charge for these things. Can that potentially cause problems with flat-based fee apps in the service? You know, you can't make an app that's $4 in the App Store, and then if you get really popular, you're going to be charged more than you're going to have charged the user. So we've got to tackle those things. But if there's feedback and there are clever ways to get around that, I encourage you, let me know. I can let the team know or contact Microsoft. And we can kind of come up with what works for you and your company. All right. This is what we're kind of looking at. You take your device, it maps the object there. You're then able to place your app, or you place your object. It communicates up to the cloud, and then every other device looking for it will be able to find that anchor in that same place. And that's really the magic. They're really unifying all the devices across all of these with this one service gives us a humongous tool that we've been missing up to this point in time for really making holographic apps that cross all these boundaries and that really penetrate into the mass market. So now we're going to get into Azure. What do we do in Azure? Here's all you have to do to create your spatial anchors. You go to create a resource, you look up for the Azure Spatial Anchors, click on create, choose your resource group, choose a name, whatever name you want. In this case, I'm going with my spatial anchors. It takes that, we generate behind the scenes, it generates that service. The things that we want to look at here in a second, it generates it. It's building that behind the scenes. We go to our resource. There are two specific things that we need to move forward. I told you we have keys. So there's an account ID. That's where that is. And then keys. And there's a key that we want to do. So these are the two things that we basically need to plug into our application to get our individual service that we're looking at. I just want to make sure that I show that to you guys so that you know where to go when you want to make one. So next, who's played with Unity? Anyone? Some Unity people. So Unity is a fantastic application. It is a game engine. It is a physics engine so that you as a 3D developer or even a 2D developer can utilize this app, and it's a free until you make $100,000, something along that line, and then you have to pay for it. If you're making $100,000 and you can't pay the $30 a month, we got some other questions, financial questions to basically go over. But it's a really good engine. It takes care of a lot of things for us. It takes care of gravity. It takes care of spatial aspects. So this is what the tool that is preferentially used. Next thing we want to do is basically go grab the spatial anchor samples. Again, this is a brand new thing out. So the best way to get started quickly is to basically hop over here, grab their spatial anchor samples. And you do that by clicking on the green button, and then you download the zip file. And then we open it in Unity. And then here's Unity. So let's look at where we are. So we've got section up here. This is our hierarchy. This is where we have all the objects within our scene. The scene is the collection of think of it as kind of a level in your game. In this case, it's a level in the experience that we're building. Here is our project section, and I'm going to zoom in on that for you guys so everyone can see it. In here, once you open up that project, you'll see that we have these sections over here. We want to drill into our Azure Spatial Anchors examples. And in here, we want to highlight and look at our Azure Spatial Anchors local share demo. And this is the one I'll show later on the device as well. Then once you clicked on that scene, you'll see that we have more things that come up in there. And the special thing here that you need to notice is we now have this Azure Spatial Anchors object. When you click on that, it brings you up properties for that guy. And you'll note that we now have this section. So we have Spatial Anchors ID and key. And that is where we paste those guys. That's all you need to do. You set up your Azure, you basically plug those values in, and now when you run the application on your iOS device, on your Android device, you are ready to go. Visual Studio 2019 preview. So I utilize that as my code editor. So in here, you'll see that we can highlight these scripts. And when you edit the scripts, you'll kind of see on the right-hand side that that's the code. But I don't want to edit in this. If you double-click it, it launches Visual Studio. And now I can edit all the code in Visual Studio. My favorite code editor. Every time I have to do anything outside of Visual Studio, I remember how much I miss Visual Studio. So if we do robot stuff with our girls and we had to use Android Studio, their keys are all messed up in Android Studio. Even like copy and paste are different. It's like, why do they do these things? So Visual Studio, wonderful, happy, safe place. And I love seeing it progress. So in here, now we're going to talk about what we actually want to code. So I know I love to see code in these presentations, so I've spent time in here giving you the ability to take, and we can walk through the code. So we start with basically, how do we initialize the anchor session? We create a cloud spatial anchor session object. That's it. That's how we start. Next is how do we basically authenticate? And as we do there, we set our authentication. Note you can also use access tokens or Azure Active Directory, AAD. Here's where we basically enter those long numbers. Now, I don't think we can use Scott's special service because this can be offline. So, what? You're all good? Okay. So there's not I'm not sure if there's a local version of this, but we'll talk about that. But for right now, throw the keys in there. It's all good. So now how do we start the spatial anchor session? So we call start to process the environment data, and this is really what you have to do for most of it. But remember, we're coding this for iOS, we're coding this for Android, we're coding this for basically on the HoloLens. So we can set up these nice if-else statements to say that if I'm utilizing, for example, in this case, if I'm utilizing the HoloLens, nothing else is needed. That's the only statement I need. If I'm running this on iOS, now I got to do a little more because I've got to basically use the ARKit and call some of their methods. So Cloud Spatial Anchor Session, ARKit. I look at the interface. I get their AR Session native interface. I pass that in, so on and so forth. That's what I have to do for iOS. What I have to do for Android, not too much different. Again, I'm calling into their AR Core library, SDK library. But this shows you really the power. Once I build this up for all three applications, all the shared code is there and all the individual code is there, and it's really easy to differentiate between the three. So we continue. Now we figured out, we've initialized our spatial anchors. We've set our spatial anchors authentications. We've started our session. You are level +1. Congratulations, you've leveled up. Here's your reward. Wake you up after lunch with some humor. There we go. So we'll keep going here. Now you've leveled up. Now we got even more code to go through. Creating a spatial anchor. This is where really some cool stuff. So creating a spatial anchor, one, where did the user click? So we need to basically figure out where the user clicked in their environment to basically put that object. What we do is we set up a vector3 type variable. And we're looking to basically get what's called a hit position. So where my gaze has intersected with a surface or an object or a person, I'm going to look to basically get that location in 3D space. And here again, we need to do a little bit different on the Android, iOS, and Windows. We create an anchor by hit testing and spawning an object within the scene. So what's called a raycast. From my eyes, there's a beam like I'm Cyclops from the X-Men coming out of there. And what I want to do is figure out where that intersects with, again, like I said, floor, chairs, etc. And then I'm able to derive this hit position. So for HoloLens, this is super simple. Android, you got a little bit more. This is my typing, by the way. Yeah, my typing. No errors whatsoever. Not real at all. So, but either way, this is a little bit more involved. You know what? Yeah, iOS couldn't be that much more difficult, right? Holy crap. That's a little bit more. That is the most complicated part of this, I think, this entire example is that one. Fire away.
Just to point out that what you're showing there with the Unity Android is using AR4 and Unity iOS uses AR.
Yep, I did, but it's always good to reiterate that. So basically, this is the way that these particular libraries require me to accomplish those same activities. But really what it comes down to is I'm basically populating this hit position value up here with whatever comes out of this individual code. So next, what is the rotation of the anchor clicked on the surface? So this is something that I've learned through Spot. It's called a quaternion. And like 3D vectors, but instead of being a position in space, it saves the rotation of that object, how it's basically rotating throughout space. So I create a quaternion. Again, that's your word of the day. You can always say, what did you learn at the Visual Studio 2019? I learned what a quaternion is. And everyone go, well, wow, you did a good job. So add that to your resume. So next thing we want to do is show the local anchor. Remember I was saying before, we want to show it while in the background we process it. So we basically take that local anchor and we apply our hit position, which again is what? Our 3D coordinate. And then we also apply our rotation. Pretty simple. Cloud Spatial Anchor session, local anchor, add AR anchor. So now you've added that AR anchor to that session that you established earlier on. So we're doing good. Next is we want to set the cloud anchor from our local anchor. So we're going to take that, we're going to generate a new cloud anchor. The local anchor is what we basically position. Our cloud anchor is what we're going to basically persist up to the Azure service. So we assign our local anchor to our cloud anchor, and then we save it. Pretty straightforward. And it's all asynchronous, which is good because we all love asynchronous, right? No one loves synchronous anymore. So we've now saved that up to the Azure Spatial, up to the service. And like I said, behind the scenes, I've seen 1 to 3 seconds, maybe as high as 6 to 10 seconds based on how good a connection you have. But for your user, by creating that local anchor, that local hologram that they're seeing, they should not see that, how it basically saves behind the scenes. So it's good developers. And then another good developer thing, we can send a little message back to the person. And we can say, create an anchor, and then we get what the identifier is. The identifier is a GUID that you basically save off for all these guys. So you have an infinite number of identifiers for all the objects you want to save. So next thing, set the spatial anchor expiration. If you want that anchor to go away after a certain amount of time, you can actually set the offset of days, and it'll basically go away out of your service. You can also, here we go. I think we're going to make another level. Create a spatial anchor, set its expiration. Oh, we're all level 2. Congratulations. Here's your reward. So I love listening for the little ripple of laughter as people get to the last comic. Oh, Dilbert. Okay, so now that we've saved these spatial anchors, how do we locate those spatial anchors? So we set up a call here. To the local anchor, you need to know their identifiers. So we set up a anchor local locate criteria. We then pass in all of the identifiers. They have to be strings, or they're GUIDs, but you pass them in as strings. And then we say create watcher. Now, what this watcher does is you create the watcher. The anchor located event will fire every time an anchor is requested. This event fires when an anchor is located or if the anchor can't be located. So now we're going to see a large statement here where we're looking at a case statement. So we're looking at our anchors located. Here's our switch statement. We got a located case. We have an already tracked case. We have a not located anchor, does not exist case. And we have a not located case. So let's fill those guys in a little bit more. So if we have the located, if it fires the located event, we basically look at that anchor. We do a found anchor, and we look at the arguments on that anchor. For the already tracked, we can do something in our code potentially if we want to, but you don't have to. But it actually exposes that. Same thing for the not located. If we want to do something based on that, maybe it was deleted or never existed in the first place. In this particular case, maybe you passed the wrong identifier. And then not located. User is in the wrong location. Or maybe the data, more data, help the user to tell the location. So basically, you may not have, you may want to tell the user to walk around scanning the room a little bit more. Maybe it doesn't have enough spatial recognition of the space. Maybe it's too dark. Maybe you're in the wrong place. But you can basically fire all of these events and intelligently tell your user how to interact. So when we want to set, now we can add additional properties on every anchor. What does this mean? Why would we want to do it? So we can set spatial anchor properties. Optionally, you may choose to add some properties when saving your cloud anchors, like when a hologram, what a hologram should be and when it should be displayed. So in this case, we basically create another cloud spatial anchors object. We grab the local anchor that we basically found in this case. And here are the properties. So hologram model, robot1. Add another property labeled, maybe R2D2. And then we, again, call the create spatial anchors, and there's our R2D2. So we can say, again, an anchor is just a location, but we got to say what we want to do with that location. In this particular case, we load a robot, because loading a robot is always good. We can update our spatial anchors, or the properties on the spatial anchors. It's pretty much the same thing. We have a cloud spatial anchor. We get the properties on that guy passing in the ID. If that exists, again, do some defensive coding. We can just update whatever properties we have on there. Maybe I want to switch it from R2D2. I want to switch it to K9 from Doctor Who, the good ones. Note, if two or more devices try to update a property at the same anchor, we will use an optimistic concurrency model, which means basically last one in, or first one in wins, and then we'll get a concurrency issue, basically telling the user that there was an error if the second one tries to update it. Also, you can't update the location of an anchor once it has been created. What you do is you must create a new anchor and delete the old one. So because you have that spatial anchor information, it's not a big deal at this point in time. You just basically update. You delete it, add a new one, add new properties. How are we doing on time? Let's see. So we can delete spatial anchors. We can pause, reset, or stop the spatial anchor session. Stopping the session will temporarily stop the watchers and the environment processing. We can also reset the environmental data. And we can clean up properties after the session. Again, always clean up after yourself, except for apparently with the new using, so we're all good. So, it looks like we're good. We located spatial anchors. We set the spatial anchor properties. We've updated spatial anchor properties. We've deleted the spatial anchors. We've paused, reset, or stopped the anchors. You are now level 3. Congratulations, you've leveled up 3 times today. There's your cookie. All good. Okay. So how do we build? I've said we're going to start this. We're going to build these for the HoloLens. We're back in Unity. If you go to Build Settings, you can quickly change it to UWP, basically, which is a Windows application. We can then switch platform, which is the button on the bottom there. Now we're building applications for that. I specify a HoloLens in this particular case. I specify Visual Studio 2019 because that's the whole reason we're here today. And we click on Build. Now, how do I do this for the Android app? Well, it's not very much different. I specify the Android as my build. I specify, in this case, when I deploy to my phone or deploy to something else, I specify that in the build deployment or development build. And that's it. One thing we're not going to touch on much today, but I want to show you guys this. This is something truly exciting about the service. We can do wayfinding between anchors that we set. So I can set one anchor. I can find that anchor, and it can say, I know, think of yourself in a museum, I know that I want to go to the Egyptian section from the Greek section. It's this way. It can actually show you a navigation series between those different anchors. We're not going to go into code on that particular one, but that has a huge amount of potential for us as developers. As you spec, here's the documentation. So after this, these are the resources I want to make sure that you have moving forward. Here's a lot of the resources I got for this presentation is under this Creating Unity app for the HoloLens. If you want to do it in different languages, again, you're not limited to Unity. You're not limited to, you have access to Objective-C, Swift, Java, C++. You can consume this service, and they have code examples for all of those. So you can take this for any particular language, at least the ones that matter. And when you have feedback, they even have a little provide feedback for the team. So if you think that GPS or some other way to set these anchors is really important, leave that feedback for the team. The more of us that basically speak up will influence how they basically do the development. Additional resources. There's my blog. I have lots of these articles will go up there. All more spatial anchor stuff will go up there. All HoloLens and mixed reality, augmented reality. We do development on Oculus Go's and all kinds of really fun toys. Stuff. Let's see, there's that. But now I want to show you actually what it looks like on the actual HoloLens. So, am I still up? I think I am. Let's see here. Let's maximize that. All right, can you see yourselves? So these are the holograms I put up here earlier, and you'll note that I can walk around these guys. Look how stable that is. And for me, it's completely stable. There it's a little jittery because it's coming through my head. But as I'm walking around, there's no jitter. And if I look at the floor, that's it mapping. Map Cameron. Fire. Oh, I'm mapping you. There you go. And so as I walked around the room, it actually has been mapping and remembering this room. So it knows what's over there. If I hadn't walked over there, it's got a range of about 15 feet for its depth sensors. But okay, let's look at the example here. So that is an application that I pinned. This is your desktop of the future. We'll give it a second. So here it says create cloud anchors, if you can read that. Configure the cloud spatial anchor session. So again, this is going step by step what we went over. So now you actually have in the back of your mind what all the code is. Start the session. Now you see the little cube. So I want to place this cube. Let's go place it over here. I want to place it, and you can see how the cube kind of maps the surfaces. I place it. Look how solid that is. So now, save the anchor to the cloud. So it hasn't saved it yet. Like I said, we've created one locally while it's doing this update. Look at that. Now it's saved it. Can you guys see the GUID that's kind of attached to it? Yeah? Okay. So now we're going to stop the session. Now we've cleared it out. We're going to create another session for querying. And now we're going to look for those anchors. So now it's looking at all the objects. And we're going to see if it finds the ones they basically had. Usually comes quicker. So, there we go. There we go. There were some ones I did earlier. I did one on your lap earlier, and you're still sitting there. Oops. Apparently I clicked through too many times. Okay, I'll place another one on this chair. Oh. Ah. I am using my phone. Here, well. All right. Can you see it now? Okay. So for me, this is completely clear, and everyone's welcome to try this on the device later. So I go through again, really? Function, volume down, done. So this is what you're seeing, that I've basically been able to take these anchors, save an object off of that anchor, send it up the cube, reinitialize, and actually come back and get those anchors reloaded. Got one there, got those ones over there, got the one over there. Oops, can you see it? Is it refreshed yet? Wait for it. Not nearly as impressive. There we go. So that's what we wanted to show off today. Can I answer any other questions? Can people see uses for this? Yeah? This was really the thing that was missing for us as developers for applications, because not everyone has a HoloLens. Only about 50,000 people have HoloLenses from what I understood for the production run. HoloLens 2 is coming out, but the ability to have all my iOS devices, all my Android devices, all my HoloLens, and everything have this shared service behind the scenes, I think is really what's going to make this a much more viable product. Cool. How am I doing on time? Is that it? Awesome. I'm done.